Hi, in this last video on algebraic proofs involving consecutive integers and such, we want to prove that some expression is a perfect square. Now, a perfect square is basically a fancy way of saying square number, but it's a bit more general. A square number is specifically some integer squared. So, for example, 9 is a square number because it's 3 squared. Whereas when we say perfect square, it's a more general thing that could be a square number, but it could also be some algebraic expression squared. So, for example, if I had 3x plus 2 all squared, this is known as a perfect square because it's some algebraic expression squared. Theoretically, if x wasn't a whole number, then 3x plus 2 wouldn't necessarily be a whole number, and something that's not a whole number squared is not necessarily going to be a whole number. So a perfect square could actually be something that's not even a whole number, let alone a square number. But anyway, in general, a perfect square is some algebraic expression or a integer squared. Right, so how do we show that this is a perfect square? Well, let's just expand out all the brackets and then hope that we can write it as something squared, right? So, to expand this out, we need to do each thing in the first bracket times each thing in the second. So we're going to do the 3x times the x, which is 3x squared. We're going to do the 3x times by the minus 1, which is minus 3x. Then the minus 2 times the x, minus 2x. And the minus 2 times minus 1, which is plus 2. Now let's deal with the second pair of brackets. We're doing the 2x times the 3x, which is 6x squared. The 2x times the 1, which is 2x. We've got the minus 1 times 3, which is minus 3x, and the minus 1 times 1, which is minus 1. Now let's just simplify this, collect like terms. We've got 3 lots of x squared plus 6 lots of x squared, which is 9 lots of x squared. Then we've got minus 3x minus 2x plus 2x minus 3x. I can see the minus 2x and the plus 2x cancel. So we're going to get minus 6x. And then finally, we've got 2 minus 1, which I can see is plus 1. Now, we need to show that this is a perfect square. So it's something squared, basically. Now, how do we do that? Well, if you think about it, if you imagine that you had 2 brackets, but the 2 brackets are going to be the same, then this is going to be 3x and 3x, right? Because then the 3x times the 3x would be the 9x squared, yeah? We also know that this constant here times this constant, so the terms without the variables, they got to multiply to give this 1 here. So it could be plus 1 and plus 1, but it can't be because then all the terms here in the expansion would be positive and you wouldn't have minus 6x. Or it could be minus 1 times minus 1 would also be plus 1. So I think it's going to be that. And if you just check in the expansion, you're also going to get minus 3x, which is this minus 6x here. So that works. And now we could write this, because it's the same bracket, as 3x minus 1 squared. So it's an algebraic expression squared, so therefore it is a perfect square. And we're done.